So SQLite. People usually say SQL, by the way, not SQL, but you can say either way. It has some features that make it unique in the world of relational databases, and we'll get into really what relational means in relational databases next time when we talk about joins. This particular one, which is one of the reasons we're using it, doesn't require you to do any configuration. So usually databases are giant programs that are run on giant, powerful computers and are not usually easy for a regular person to set up on their own home computer. But this one is super easy. You just install it, boom, you're done. You don't have to do any configuration. It also doesn't require a server. Usually they need a dedicated computer that runs the database. In this case, we can just use our own personal computer or whatever computer you happen to be on. If you're on a library computer, you can install it right away on the library computer. You don't even need admin access to be able to install this database. It stores the actual data and all the database settings in a simple file, one file. Usually databases of this type have massive number of files all over the place, many folders full of files with different settings and configurations and programs, all of that linked together. This is just one simple database file. It works on Mac and Windows and all the usual suspects, Android, Linux, and all the operating systems you know and love. So it's not a problem having whoever you want working on a project, all sharing an SQL database because they can all run it on their own computers. This is a unique feature of SQL. Manifest typing means that the data type, in programming you have ints and floats and booleans and all that fun stuff. In the world of the SQLite database, the data type associated with any piece of data depends upon the piece of data. So it manifests its own data type. If you put an int in there, it will be an int data type. If you put a float in there, it'll become a float data type. So the data type is determined by the data, not the other way around, which is often if you have a pocket for data that is of the int type and you put a float in there, it'll get turned into an int in many programming environments. In this case, the data type of the data actually determines the data type that is interpreted. Doesn't seem like a big deal to you because you don't know any different, but that's a major difference from many of the other SQL database systems where the fields, the columns in your data set are of one singular type. And if you put anything else in there, it gets converted to that one singular type. That's not the case here. You have a column that's typically Booleans and you put an int in there. Well, that's an int now. It's not a Boolean. Small footprint. The files are actually small. The overhead is small. There isn't a lot of processor power needed to run this thing. It's a nice, discrete program. Source code is public domain. That means it's accessible and available to everybody in the public. And it is widely used. For example, if you happen to have used a web browser any time in your life and put a particular website in your favorites list or your bookmarks tab, then you're using SQLite. That is, all the major browsers use SQLite as the data storage for favorites lists, for bookmarks, for your history of web pages you've gone to in the past. Pretty much anytime they need data storage for settings of the browser, this is all stored in SQLite in all the major browsers. If you have ever used a mail program on your phone, like Mac Mail, the iOS mail program on your iPhone or your Android mail program, that is going to be using SQLite to store the messages. So the data set, the data that is in your phone list of all the messages is being stored internally in the phone in a SQLite database. So, widely used. There are many other places it is used. That's just two simple examples. Let's talk about setting it up on your home computers if you haven't already. If you have OS X, you already have SQLite. OS X recent versions come with it installed. It doesn't mean you're getting the latest version of SQLite, but it means that you at least have some version of it. And we are not really very particular here. Whatever version you have is probably good enough, but if you have trouble, you can always upgrade. If you want to upgrade or install, no matter what system you're on, Windows or Mac, there's source code here, and there's a option which has the amalgamation with configure script. If you click that link, you'll see what I'm talking about. That's a pre-release snapshot. That means that it is before the official version has been completed. This is your latest bleeding edge version, which might have bugs, might have problems. So you actually want the kind of definitive versioned source code that is officially released, meaning they think they've fixed all the bugs. This would be the one that you would want. So the amalgamation with the configure script is the one that you want. All right, so I've given you the link there. Download that. And in the readme.txt file that you're going to find in there, there are instructions for what to do to install that. So follow those instructions. All right, you can do that later. Don't worry about it right now. If you follow along the lecture, it's probably easier anyway, since I'll be doing commands that will take you time to write on your own. All right, so assuming you've got it installed, what do? Well, you go to your command line, your terminal, and you type in the command SQLite 3. That by itself will launch SQLite 3. But if you want to have a particular database file that you load up, then you can put that name of that file here. So assuming either you already have a file called databasename.db, or you intend to create a new file to store whatever data you're putting into your database by that name, put that name second. That's optional, right? If you just run it like this, anything you put in the database will be deleted once you quit the database program. If you mention a file name, any changes you do and data you put in will be saved in that file. So that's probably what you want. SQLite 3, the name of the database you want to be using. If that's new, fine. If that's an existing file, fine. Just make sure you know what you're doing. All right, so let me show you that from my computer. I would recommend, if you have nothing better to do, use Visual Studio Code as your terminal program if you are on a computer that has it. So we have in Visual Studio Code a built-in terminal. You can go to Terminal, New Terminal, and pop open a terminal window. So you can use the regular terminal program that you have on your computer, whether that's Mac or Windows terminals. But this one is an environment you're becoming more familiar with anyway, so maybe just use this one. All right, so SQLite 3, one word. Give it the name of a database like foo.db. And boom, I'm in SQLite 3. Let me zoom in so hopefully you can see my commands better. I'll get rid of those files. Okay, so SQLite 3. You'll see your version number there. Just make sure it's a relatively recent version number, 3 point something should be fine. If you want to quit, there are a series of commands that start with dot, and the quit command is one of them. So dot quit. Any sort of special commands that tell the system what you want to do are starting with a dot. So quit is your quit command, and you return back to your command line on your computer. I'm going to restart it again, SQLite 3 foo.db, but that is how you get out, dot quit. All right, so what do we do in a database? We do one of four things. We create data, we read data, that's already there, we update data, that's already there, and we delete data, that's already there. Right, so these are affectionately known as CRUD, create, read, update, delete. And these are the four tasks that you do almost all your time working with data in a database. Here is the definition of the English language word CRUD, in case you weren't familiar with it, which I'm sure some of you were not. CRUD from WordNick or any reasonable dictionary will be a noun, a coating or an incrustation of filth or refuse. Or another definition, something loathsome, despicable, or worthless. And here's my facetious little message here. It is not accidental that the acronym is CRUD, right? This is insider joking, sarcastic terminology that you regularly come across in the world of technology. So the people who came up with this create, read, update, delete, they were having some fun and they called it CRUD because of this word definition. So that is really the plumbing work of data, right? You're essentially a plumber when you deal with data like this in a database, and you do all the scraping and the munging and the analysis that we've been doing. This is plumber work. It's like going into a toilet and pulling out all the stuff that's clogging the hole. So the people who do this a lot, that is essentially how we consider it. It is the dirty work that's necessary to get the job done. So how do you create? I'm going to go through each of these four things: create, read, update, and delete. We're going to see the things that you create and how you do them in the code. So before you do anything else, you have to make what we call a table. This is directly corollary to what we did in spreadsheets with a sheet, right? So when you open up a spreadsheet file, you have sheets, these tabs that you can kind of click through, which are all their independent documents. So we have to make an equivalent of a sheet, and that is called a table in the world of databases. So we have to figure out what is the name of the table we want to create. Think of it like a spreadsheet sheet. What are the names of each of the fields, meaning each of the columns that you want in that spreadsheet-like data set? And what are their data types? Remember that we have manifest typing in SQLite, meaning I said earlier on that it doesn't matter what the column's data type is, it matters what the value is that you put in there. The data type is determined by the value, not by a setting you apply to an entire column. And that is sort of true, but you can still apply a setting to the column to make it easier for you and for the database to make a best guess at what data type to use. So we typically do assign data types, even in SQLite, which doesn't exactly require them. It is a convention to do so, and it is required in every other database system you're going to use, including all the other SQL-based systems. So we're going to do it the standard way by assigning a data type to a column. That doesn't mean you can't put other stuff in there, but we don't generally do that. So anyway, so you can pick from a couple different data types in SQLite. Every database system has its own variation of these data types, but they're all generally about integers, floating point numbers, strings, bigger quantities of text, and just bigger binary data of any kind. So you'll see the same conceptual data types are in all database systems, but SQLite particularly has a data type called integer, a data type called real, which is your float equivalent, a data type called numeric, which could be either or, a data type called text, which is your string equivalent, and a data type called blob. So blob is arbitrary data in a byte format, in a binary-like format. You just dump some binary code in there and it will be saved. It's not string, it's not int, it's not float. Any one of these fields could be designated as what we call the primary key. What do we mean by that? A primary key is a guaranteed to be unique value in every record. We'll get into this in a second, so this will make sense. But every record has to have at least one value that is unique and different from that equivalent value in another record. So let's say we have a table of students, which we can make in a second. Student names, student email addresses, their majors, whatever else you want to know about a student. Let's say their names, their emails, and their major in school. There might be two students with the same name. There might be two students with the same major, but there wouldn't be two students with the same email address. It's a one person per email address system, right? So the way email usually works is each person has their own unique email address. So that would be a candidate for choosing as the primary key. It's a value that's guaranteed to be unique in each record, right? No two records will have the same email address. So you want to figure out at least one field in your data set that is guaranteed to be unique for each record. That's what we're going to do initially to create our data set. We're going to create a table. That's the structure within which we're going to store the records. So once we have this table made, we can now start to store records. So how do you create a table? Here's an example set of code. There's a command in SQL, create table. You would name your table, whatever you want to name it, like students. And then in parentheses, and followed by a semicolon, you would indicate all the different fields. There's going to be a field I'm calling ID, which is going to be of the data type integer. And I'm telling SQLite I want this one to be the unique one for every record. So if I try to put in two student records that have the same ID, it will not allow me to do that. I'll get an error. So this enforces uniqueness by telling it that this is a unique field. First name is just a string, last name is just a string, email is a string, city is a string, state is a string, county is a string. And here is a special field I've added, which I'm calling created. And the database, as most databases do, has the ability to store the time and date at which you entered any record. So this is kind of like a bookkeeping feature. You can log automatically the timestamp, which is a kind of an integer version of the time, into this field. If you make it into this data type called date time, it will automatically log the time and date at which the record was created. So each time I create a student, that gets automatically filled in. So you would write this in your command line. So if you wanted to create this table, you could go to your command line here. You can actually just copy paste it. The multiple lines will have this kind of prompt in front of them, but until you hit semicolon, this is all considered one big command. And when you hit enter, that gets committed. Right? So you would have your table created there. I can just prove to myself that my table is there by saying .tables. That's the way you see a list of all the tables you've made. And there I go, I've got my students table. So that is what I intended to do, was to create a students table. Now, if I want to prove to myself that I've set up all the fields correctly, there's another optional kind of command you can run, which is schema. And then to give it the name of the table you want to look at, students. And you'll actually see the create statement to create that table. And it'll have all the data types and the settings on each field. And you can all make sure that you've done it correctly. All right, so schema is a way you check the schema, meaning the fields and their data types. And tables is the way you see the list of all the tables you might have created in this database. So now we're ready to insert data into that table. So you can specify the data you want to insert. You can say insert into students. I can say which fields I want to put data into. Let's say first name, last name, email. Let's just leave it like that. And then values, and then in parentheses, foo, Barstein as my first name and last name, and my email, my fake email is this one. and semicolon always ends each SQL command. And there you've got a record that has been entered. So notice I only entered in the first name, the last name, and the email, which are just 3 of the 1, 2, 3, 4, 5, 6, 7, 8 fields. None of these fields I've said are required, so it's okay to enter in my case, in the way I've set up this table, it's okay to enter in null data, meaning non-existent data in some of those fields. Definitely you cannot do that in the primary key field. Remember, the primary key is unique for every record. But notice I didn't even say any data to put in the ID field. I just said first name, last name, email. The database will automatically assign me a unique integer as my primary key. So that's taken care of. The ID field is kind of automatically taken care of by the database. Remember, I also said the created field will be automatically taken care of by the database. It's going to insert the current date and time at the moment the record was inserted into the database. The other fields that I didn't enter, city, state, and country, they're just going to be null. So they'll have null values automatically assigned to them. And if you're not familiar with null values, it just means no value in programming terminology. There's usually a special data type, the null data type or something like that, that represents non-existent values. So anyway, I can prove to myself that I have the data in the database. I can do select star from students, semicolon. And I should see any records that are in that table returned to me. So I've got a 1 as the ID before that pipe marker, foo as the name, Barcine as last name, FE1258 at NYU, and then look at all these blank fields, meaning null values for city, state, country, and then the time and date at which this was entered. Now, if you're paying close attention, you might notice that the time is wrong. All right, this is what used to be called Greenwich Mean Time, but is now called UTC, Universal Time, and it is the time zones all start from Greenwich, England. So if you happen to ever go to Greenwich, England, you'll see either at the actual Greenwich, England park, which is the main park that they have here, or just in the town along the streets, you'll see little metal signs on the ground that say this is the line of the time zones. And that's where time zones start. So this is universal time. It's kind of the neutral, not plus or minus any hours from the mean time. So that is official Greenwich time in Greenwich, England, also called UTC time. So by default, that's the date time zone that the date time data type will use. So that is the way you insert data. So insert into the table name. You put a list of the fields you want to put the data into, and then the word values, and then a bunch of the values you want to put into each of those fields that you mentioned earlier. You can import from a file. So if you had a giant data file, like you are now becoming familiar with, you can import that into your table automatically. You first, let's assume you're doing CSV files, which are the most common when it comes to relational databases. The row column system of the CSV matches perfectly with the row column system of a spreadsheet and of a database, relational database. So you'd want to set up your environment so that importing a CSV works. I have an example file, a CSV file, which I'll show you I have already downloaded, but you can click to download it there. If you have that file, you'll notice it is, I hope I can pop it open. Oh, my terminal is gigantic. Hold on a second. So you have a file that has fake students' names. They're fake names, they're fake email addresses, they're fake cities and states and countries, and also IDs, which might be a problem. Once we try and import this file, you'll see I actually already have an ID number 1. Remember, I just inserted a row manually that was row number 1 ID. If I try to import into a row and I say I'm going to use row number ID number 1, that'll be a conflict. Remember, that has to be a unique value. So anyway, we'll get to that as we go, but you can't do that. If you already have an ID being used, you cannot use that same ID number a second time. So I'll have to solve that problem. Anyway, so these are settings that you can apply to your SQLite environment. So I can say mode CSV. What that will do is it tells SQLite when I import a file that the separator will be commas, the breaks between records will be line breaks. So all the usual delimiters that we're used to and separators that we're used to in CSV files, SQLite will understand it has to be using those. So looking for commas and line breaks and stuff. So I can do mode, so I'll put that down there, mode CSV. There are other modes, but that's the most common one for importing. And then you can say headers on or headers off. If you say headers on, which for this data set I will do, I'm telling SQLite that the first row in this file has the header names on it. You know, in some cases, CSVs don't have that. They're just the data themselves, in which case you would say headers off. And that tells SQLite that the first row is actually just data. Right? So you would make your decision of whether headers are on or off, dependent upon whether your first row is actually this or not, headers or not. Right? You can import other file formats, but JSON, which is another file format, a plain text file format we've discussed, does not get natively imported into just about any relational database system. So that would not be imported automatically. All right, so you can download that file if you want to. Now, the problem with importing directly the file I just downloaded, as I mentioned, there are a couple problems, but the big problem is the ID field is already present. And I already might have some records in my table which have conflicting IDs. If I tried to do an import statement, let me just show you what that would look like. Well, I do import, I'd say which file name it is. In this case, it's in the same directory called studentlist.csv. On my computer, that's where it is. This is just an indicator of same directory. You can not do that. You can just say studentslist.csv to not confuse you. And I can say what table to import that data into. So that would be my students table. And I can hit enter. Now it probably didn't work. Let's take a look at all these errors. Did it or did it not work? Well, let's take a look. Let's check out what's in that file. Select star from students. Let's check out what's in that table. Okay, I've actually got almost all the records imported. Let me go to the very top here, record number 1, and notice that it didn't import record number 1, Gibby Luckwell. Gibby Luckwell, fake name, could not be imported. There was an error importing Gibby Luckwell's record because I already had Foo Barstein with ID number 1. And remember, you can't do that, right? You cannot import records with the same IDs because the ID is the primary key, and that's that. You cannot have two of the same. So there would have been an error output. You know, there's probably a lot of errors, but it would have said, you know, cannot import because the primary key is in conflict for that record up there with the ID number 1, which is in conflict with the other record I already had with ID number 1. Let me delete everything from this table at the moment. So delete is how you delete. Delete from students is the name of my table, semicolon. That'll wipe out all records. So if I now look and see what's there, there's nothing there. All right, another feature, if you noticed when I imported, was that there was no timestamp added, at least not that I can see. Yeah, it's not there. We're missing the timestamp field. I've just deleted all the records. I also just pointed out there's no timestamp. And we have this conflict with the ID, right? That the ID was already in existence that we then tried to import, and that created this problem that we lost a record, which is bad, right? You don't want to be losing data because that might be important. So the main thing you want to do is not import primary keys, generally speaking. Leave it up to the database to assign primary keys to each record and make sure they're unique, but don't go and tell the database which primary keys to use. You can do that, as I just did, but you might get these conflicts, which you don't want. So there are a couple ways around that. I can just delete all the primary key information from this CSV file. I can just go in and either write a program or manually go in and remove the ID column. That's a little too much work for me. Another solution is just to make sure you don't have this conflict by creating a temporary table. So I'm going to do that. The temporary table is going to match exactly the data that's in the CSV. And it doesn't have any other data that I've entered in my database because I don't have this table in my database yet. So I'm going to make a brand new table with a set of fields. Remember, notice that created is not here. There's no automatically filled in created field. So all the fields that are actually in existence in the data CSV file, I'm going to make a table to match. So let me do that. There's actually an extra comma on that last line right there. I should remove that. I already made a version of this that I should use. So let me just, I took off that comma because I tried it out just earlier and I had that comma problem. But you can copy that and I'll fix that slide to get rid of that extra comma, or you can do it right now on your own, but that's causing the problem. So let's get rid of that comma and do it again. And there we go. So we've created a table. Let me just prove that to myself. Dot schema to just prove that the schema is correct. Temp table. All right, so I've got a table created and it's showing me the schema. Now what I can do is import my CSV into this temporary table that has exactly matching fields. and no extra, no more, no less than what's in the CSV, exactly the same fields that are in the CSV. So I can import into that. So I can do the dot import at this point. The name of the file is students.csv. The table I want to put it into is not students, is temp table, this temporary table. And that won't have student data, is it called? Student list, that's what it's called, student_list. And that's going to not have any problems. Oh, I didn't turn headers on, or I did turn headers on. I don't know. Let's take a look at the data. Select star from temp table, semicolon. Go to the top. Did I import the headers accidentally, or try to import the headers accidentally? I'm not sure. It's all good. So everything worked out well. We don't have a created timestamp because this table, I didn't say to make one. This is the special table that only has the fields that are in the CSV. Now what I can do, so now I'm ready to actually get this into my real table with the timestamps and the right primary keys. I will copy. So really what I'm going to do here is I'm going to copy everything from this temporary table, and I'm going to insert it into the students table, the regular table. I actually don't need the ID, so I can get rid of that, but I'll leave it there because we don't have any data in the students at this point. So I have a blank students table. I'll just take everything and dump it into. So I'm going to insert into the students table the fields ID, first name, last name, email, city, state, and country, all the records that we have in the temp table from the temp table. Notice I'm not saying to insert the created time and date. That will automatically be handled in this case appropriately by the insert command. So let me copy that, paste that into here, and now I've got it. So if I do select star from whatchamacallit, students, then I should see the timestamp on each record, and there it is, yes. And because I didn't have any data in the students table, I did import the primary keys that are in the file, and it didn't have a problem. But you could have not done that as well. Okay, so I've got data in the database. I've got all the fields I want, including the timestamp, plugged in to each record. But remember, the process here is you have to first make a table that matches exactly the fields that are in the CSV, import into that, copy from there into your normal table. And then I can delete the temporary table. I can say drop temp, what was it called? Temp table or temporary table? Temp table. Okay, so drop temp table. Drop table, temp table, sorry. All right, drop table, temp table, and that is now gone. If I look at my tables, just the students table with all the right fields. The data looks like CSV data. If I do select star from students, this all looks like CSV data, which is intentional. I had actually told SQLite to do that. I said .mode CSV. That actually is one of the implications of changing the mode. That means that when you look at the data, it'll look like the mode you said it should look like. I could say .mode, I think one of them is called list. And if I look at that, it'll look with these pipes between the data. There's another one which you all love at this point, markdown, .mode markdown. I hope some of you are starting to appreciate markdown. And if I look at that, it'll look, well, I'm zoomed in, so it looks kind of line broken, but if you had this on a normal zoom out, it would look like a very nicely formatted markdown table, which has pipes, but also nice separators between the columns, lined up nicely. So you can choose your mode. .mode list is, I think, the default, and that is probably the most, I don't know, maybe the markdown is easier to read, but this one takes up less space. So if I do the select statement in list mode, you get pipes between them. Maybe markdown is the best. I don't know. You guys can decide for yourselves what is the best preferred visual look to this data. One of the nice things about the markdown mode is you can copy and paste this into a markdown file, and it'll render as a nicely formatted table on the web. So that's a clear advantage of markdown version. Okay, so we've, again, conceptually imported the CSV into a temporary file with fields matching exactly, moved that data by copying it into another table which had the created field added automatically. And then I can delete that temporary table because I no longer need it anymore. All right, so how do you use this data? So for example, if I do select star from, capitalization, by the way, is not important in SQL. Used to be that everything was capitalized in SQL, all the keywords like select and from, but these days it's not. Select star from students is one way you can get everything. So that's the way that we've seen until now, that you just get all records that are in the table called students printed out. I'm going to switch modes. Dot mode CSV, so it doesn't take up as much horizontal space and doesn't line wrap. Okay, line wraps a little bit. Okay. That's one way you can get all the records. But what if you didn't want all the records? What if I wanted only the records of students in Oakland, California, for example? I can say select star from students. Sorry, something just happened. Select star from students, where city, remember, is one of our fields, equals, in quotes because it's a string, Oakland, and state equals, in quotes, California, semicolon. So that statement down there will select me only those records that match. The city is Oakland and the state is California, right? These are the column names that I want to check against, the field names I want to check against, and these are the values that I want to check for. And because these fields are strings, text data types, you put quotes around the values, like in most languages. All right, so here they are. I've got here the matching records. So we've got Winona Hurrian and lives in Oakland. We've got Alita Stubbings, Benjamin Bales, and so on. These are all imaginary students that live in Oakland, California. So you see with a simple permutation of that query, that kind of request we're making to the database, I can filter down the results and get only those results that match some criterion. So in this case, I've applied two criteria, Oakland and California. There might be other Oaklands, of course. I can say city is Oakland and state not equal to California. So let's see if there are any other Oaklands. Nope, nothing. So you decide what your criteria are. Let's say where first name, which is one of my fields, is Benjamin. Right? Get all the Benjamins. Well, there's only one, Benjamin Bales. Let's say first name equals Betsy. None. So you can just poke around, try out whatever queries you want. So you can do one, you can do multiple. If I did where city equals Oakland or city equals San Francisco, then I would get either or, right? So you can use the or keyword, just like the and keyword, to do logical permutations, right? So I've got actually nobody from San Francisco, but if there were any records from San Francisco, they would have shown up as well. So you can do select star. Star, by the way, I haven't mentioned this, but the star here matches all fields. So let me just focus on that for 1 second. If I said select first name, I can't type first name from students where city equals Oakland, that's only going to show me the first name field in the results that I get. So that's what that star means in the beginning. That star means all fields. So I'm asking, just give me all the fields. But if I want, I can specify which field. So select first name, comma, last name from students where city equals Oakland. And I then get both of those, first name and last name for each student, right? So you can specify with a comma separated list of field names or a star which fields you want to get. If I wanted to get all the students whose name starts with BEN, then I would do select, let's say first name, last name, doesn't matter what fields we're getting, from students where first name, you would use the keyword like. So instead of equals Ben, you would say where first name like, could be capitalized, could be not, doesn't matter. And Ben %, that's instead of star. So %sign is the equivalent in SQL to what you're maybe used to in regular expressions as a star. So let's try that, semicolon. And we get Benton, Benjamino, Benjamin, Benji, Benjamino again, and Benedicta. So we've got all the matching first names that start with Ben. You can put that in the beginning of a text. So I can say, %sign Moss. Oh, nobody. %sign IE. Oh, lots of those. Gary, Christy, Joni, Haney, Angie, Cobby, Freddie, Bucky, right? All the names ending in IE. Let me just point out one thing. There are functions. Select star from first name. I'm sorry, from students. Let's just do last name, first name. From students where city. I can do a function like lower city equals Oakland. And so regardless of how the data is being stored, I can say, go run the lowercase function on that data, get the lowercase version of Oakland, and match it to that. So I can do select first name, last name from students where city equals Oakland. I'm just picking Oakland because it's going to be a smaller set of results. It's easier to see on the screen. Order, I'm capitalizing it, but that's just for your attention. It's not necessary to capitalize. Order by, and then I can pick which column I want to order by. So order by, I don't know, last name, and then I have to tell it either in ascending order or descending order. So I'll do ascending order, that's ASC. Descending is DESC. So let's do ASC, and I have examples of this in my notes and the slides that we'll hit, I'm sure, if we look through those. But since we're on this topic, that's how you would do this. And hit enter. And there we go. I've got in ascending order by last name. That's Bales, Hurrian, Pucker, Stinton, and Stubbings. So that's correct. We've got the data that we want. It might look nicer if you do select last name first from students where city is Oakland, order by, sorry, capital Oakland, order by last name descending. So that way, the last name column will show up first, and you can clearly see that they are, oh, I did descending order, sorry, in descending capitalization, or alphabetic order. So yeah, the order by is your way of ordering by. If you want to see the most recent records that you've inserted, I could do select star from students, order by created. Remember, we have a timestamp, which tells us when every record was created. And I can just say, give me the most recent one. And I can say order by created in descending order. So the most recent date is the highest numeric value. Dates in this time, data type, in the date time data type, dates are actually internally represented as integers in a form called a UNIX timestamp. And what I'm asking for here is the highest number integer, right, first, and then the lowest going down. So get me the highest numbers in that timestamp field first, and then lower numbers going down. So that's reverse order of time. And that's that. I'll do that, and we'll just see all of them. So, okay, so the most recent, I'm not going to go through all these. Anyway, that's how you would order by timestamp, which happens to match the order of the ID numbers. Let me just make sure I did that correctly. Yeah, that should be okay. You can also limit, which means only show me 10 of those. So that'll get you the data in reverse order and limit it to 10. Now you might notice I would have expected the numbers to go in reverse order. I don't know if anyone else would have expected that as well. We think that we inserted, these are 1,000 records of students. I would think that record number 1,000 would be the most recent one because we went in our CSV file in order, line by line, and imported them. And there, so we should see 1,000 showing up first, then 999, then 998. Anyone want to guess why that isn't the case? Why am I seeing them in increasing order from 1 on up rather than descending order, which is actually what I asked for. When I said descending, you would expect the last one inserted to show up first. At least that's what I would expect. It took less than a second, I'm sure, to import all this data. UNIX timestamps, the internal format that are used to store these dates. Let me just look up on Wikipedia what those are for you. So you get a sense for what a timestamp is, also called an epoch timestamp. All right, UNIX time, there we go. That's what I needed. UNIX time is a way of counting time starting from the 1st of January, 1970, and the number of seconds since then. So that's why it's an int. It's the number of seconds since the beginning of the day, January 1st, 1970, which is, as it says here, an arbitrary date. They just picked that date for simplicity. They had to start somewhere, just like, some people like to start with the birth of Christ. Well, we start with January 1st, 1970 in counting time. So that's just the way it is. Unix people have picked that date, not Christ's birth. And this is the number of seconds since that time. So it's an int with a number of seconds since January 1st, 1970. So you would assume, if that's the way internally this database is storing dates as integers representing the number of seconds since this date, then if all these records were imported within 1 second, they would all have the exact same UNIX timestamp. So that's my educated guess as well as to what's happening. I haven't mentioned all CRUD, so let me just go through some of the other CRUD. Updating records is easy with the update command. So we've seen how to create a record. We use the insert command. We've seen how to delete a record, although I haven't gone into that in detail yet, so I'll get to that in a second. And to update a record, I can do the update command. So I can do update students table, set first name to Bob. And I apologize if there are any Bobs here, but your name is going to be used pervasively here. Set first name to Bob, where city is Oakland. So as an example, I'm going into the students table to do an update, to modify some of the data that's in there. I'm setting the first name to Bob for everybody, for all records where the city is Oakland. So now everyone in Oakland has the name Bob, the first name Bob. So if I do select star from students where city is Oakland, they're all going to be called Bob. Bob Hurrian, Bob Stubbings, Bob Bales, Bob Pucker, and Bob Stinton, right? The point here being the update command is how you do your update. And the where, just like we saw with the select command, which is your reading command, the where is how you limit which records this is going to apply to. So I haven't updated everything. I can do select star from students just generally. Let's just do all California, where state is California, to keep it a little bit smaller than it would be. California. Right, they're not all Bob, but the ones that are in Oakland are Bobs. That's Bobby, not Bob. Anyway, so the ones that are in California include Bobs, but also other names. Because my update command didn't include everyone in California, it included only those people in Oakland, right? So the where clause is really how you limit the effects of what you're doing. I can update update students, set city to Oakland, where state is California. All right, now everybody who lives in all over California is now going to be dumped into the city of Oakland. So let's go do a search for everyone in California now. And lo and behold, they're all residing happily or not in Oakland. Right. So anyway, this is just showing you how you'd modify any given record. Usually what you're doing, but not always, but usually what you're doing is you're picking individuals by their ID, which is unique, and updating them. So let's say I want to update Julian Picton. I can say update students, set, let's say, city to, I don't know, what's another one? Juan, where ID is 777. So usually your updates are limited to a small set. I mean, it's not very common that you update large swaths of records at once. So this is how you'd update a single record. The ID is always unique. So if you want to identify a unique record, that's your value that you want to be looking at, is the ID value. Now, everyone in California except Julian Pickerton resides in Oakland. All right, so that's your update command. If you actually want to update the table, not any given record, there's a alter table command, which is another form of updating, but just the structure or the schema of the table will be updated. I won't run that one myself, but that's how you would update the schema of the table, even after you've originally created the table. And deleting is delete from. So you would again limit which ones you want to delete based on the where clause. So you'll see in SQL, where clauses are your friend, right? So delete from students where city is Oakland. Now we're wiping out the city of Oakland, except for one lucky fellow whose name happens to be Julian Picton, who lives in San Juan. All right, so if I now select everyone in California, we've only got one person left, because I deleted everyone that was in Oakland. Previously, I had made everyone in California live in Oakland except for that one record. Okay, anyways, that's the idea. You can play around with these on your own. I won't spend too much time on the delete, but you just say delete from table name, and you indicate which rows to delete with this where clause that you put at the end here. If you want to delete an entire table, let me just delete all the records for a second. Delete from students. That would delete everything. I'm not going to do that, but that would just wipe out everything. You're not doing a where clause. It applies to all records in the table. If you want to delete the whole table, drop table students. That would wipe out that table from memory. It's gone, right? So I won't do that, but that would completely erase that table, that schema. It's all disappeared. So different forms of delete. You can delete records, or you can delete tables. You can update records, or you can update the schema of tables. Let me just show you. I have a set of data that is from the US Census. So we'll work with the data from the US Census, and that includes school district information. That's the name of each school district, what state, the lowest grade taught, highest grade taught, geo-coordinates, meaning where on the map is it, and the primary key, which we'll look at in a second. All right, so one of the nice things about this data set is it has the population of people in this particular data set for every school district, and how many housing units, I mean, how many apartments or how many houses are in that area that that school district serves. 2010, for whatever reason, seems to be the last date of the census that included the population and housing unit numbers, which is why I'm using 2010 data, not 2000, I think the more recent one is maybe 2019. They dropped this from this particular data set after 2010, so I thought it was nice to include it, so I'm using this older data set. But the differences are probably not big in populations and in housing units and other details of school districts. They tend to change very slowly. So anyway, there is a set of fields that we can create. So I'm going to create a table called SD, which is going to be our data set or our table for this data set. Copy that. I've indicated the primary key is the GeoID. The GeoID is a particular identification of a particular geolocation in the census's way of storing data. So if you look at their reference sheets about how their data sets work, GeoID is just a unique value for each school district. So that's why I'm using this as the primary key here. So making a table with a primary key and all the fields for all the different values here. If you want to see that you've made that table, I can go and say .tables, and I've got now the SD table I just made by copying my own code, this code here. You don't need the drop table thing, just use the create table. All right, let me look at that data set for a second. If I click that link to get to the census data set, you actually can download the data from here. You can look at some descriptions of the data. All right, so I've created a table that will store this data. I've made sure it's there. And if you want to check the schema, you remember you can use the .schema command to make sure all the fields are the values you want them to be. And now I can import the data. I've got a CSV file I'm linking to that I've made for you from their data set. I've downloaded it and just made sure it's okay. So you can download the comma separated values file here, store it into wherever you want your data to go. So I already have a folder set up. I'll just save it there. And I've got sd.csv now in my folder. Remember to turn on mode as CSV before importing CSV. Turn on the mode, because that makes sure it looks for commas as a separator and all that stuff. So mode CSV in case you change it to something else. Headers on, because this data set has headers. And then I can import. So import, I'm sorry, it's .import. What did I call the file? sd.csv, okay. Import sd.csv into the table called SD. In this case, I can import directly into the table I made because the table I made matches exactly the fields in the data set. They already had a unique identifier in their data set, which was good. So I included that as one of the fields in my data set. So everything matches, and I didn't include a created field with an automatic timestamp so that it would just be easier for us to import this into our table without that fuss. Let me now go to some of the kind of interesting stuff. So I'm skipping ahead a little bit, but I just want to get to some of the things we haven't talked about already. And I'll let you read through some of these notes later. But so you may want to say, okay, what are the smallest school districts? This is a query that will tell you the 10 smallest school districts in the country. This is countrywide data. Select the school district name, that's one of our fields, right? It's just a text. School district state and the population from that table, ordering by the population field in ascending order, meaning smallest first, then getting bigger, and limit, like we saw earlier, just give me 10, limit 10. So do that filter, show me all the records by population, but then just clip off the top 10 and show me those. So as you see, there are these interesting school districts called school district not defined, water, in various states with 0 populations. These are essentially bugs in their data set, errors in their data set, or technical things that they've included that don't make sense from our perspective, right? So you might want to go in and delete all school districts where the population is 0, because there's no school going on if there's nobody living there, right? So I can say delete from SD where SD pop to 10 equals 0, and that would wipe out all data set, all records where there's nobody living there. Let's do it again. Select by population, order by population. And now you're seeing something interesting. So there's a main population 1 school district called the Lincoln Unorganized Territory, the Knox Unorganized Territory, school district not defined, some kind of a nameless bug in the data, Glenwood Plantation. So I don't know, I haven't looked into what any of these are, but these obviously need further research to see what's really going on here. I'm not entirely sure. I don't know this data very well. But some of these might be real school districts. Some of these might be just areas that could have a school district but don't currently. I really don't know. All right, let's look at some of the functions you can do. I can do averages, minimums, and maximums, just like in a spreadsheet. I can do counts. This is how many school districts are there. I can run the count function on the unique identifiers of all school districts from this table, meaning count up how many unique IDs are there. There are 10,871 school districts that are currently in my data set. Remember, I deleted some that have no population. There are some others that might be bum data, but this roughly anyway, something like 10,000 something school districts. I can say how many are there in New York by just doing a where state is New York clause. So count up however many unique IDs there are from the school districts table where the state is New York. So 668. It's a lot. I can do averages. What's the average population? Let's do that in New York, since we're New York centric here. New York University, after all, where SD state equals NY. So what's the average of the population value for every record? So this is just like a spreadsheet. The average population is 28,631. That's pretty big. We can add them all up, add up all the populations from New York, or let's do Minnesota. I already have that. I'm selecting the sum, another aggregate statistic, of the populations of those records where the state is Minnesota. So 530,000 people living in school districts in Minnesota. So let me keep going. So we've got the, some of these functions, just showing you can do counts of how many records match. You can do averages of how many records you've included in your set. You can do sums, you can do minimums and maximums. The same stuff we saw as spreadsheet stuff, it's all available here as well with these function calls. Grouping is the last thing I wanted to hit before I'll quit for the day. So grouping is an interesting thing. I can group together some of the records and then run aggregates by group. What I mean by that, it's different from what I just did, where I essentially with this one, I grouped up all the records that are in Minnesota and did a sum statistic on them. or I can do, all the records in Minnesota and do an average on those. So there are these grouping abilities, kind of one-off grouping. Sorry, AVG is average. I can do these one-off groupings where I just take one group and do a statistic on them. But what if I wanted to make a bunch of groups? Let's say all the school districts in each state grouped together and run functions on each of those individually. I can do that as one command here. So that's what I'm getting at with this kind of feature here. Let me give you an example. If I didn't mean to run that so quickly. If I did a select like this, where I'm counting up unique IDs from the school district's table, grouped by SD state, by the state. What does that show me? This shows me how many unique school districts there are within each state, but it's not showing me which state is which, right? I can't see which states each of these are. So instead of just showing the count, I'll show the name of the school district. Let's say the state, actually the state is actually the thing that makes the most sense. The state of these results, which state, Minnesota, New York, California, etc., and how many school districts are in each state, grouping them by state. So there we go. I've got the different state acronyms or short codes with their number of school districts. So remember, what I'm counting here is the number of unique IDs of records, meaning the number of records, which each record is a school district, right? The number of school districts and the state name, and I've grouped all the school districts by that state field. So all the school districts in Ohio are in this one result of count. All the school districts in Oklahoma are counted as well, separately, right? So I'm in this case doing multiple groups, not just one group. I'm doing lots of different groups by state, all the school districts grouped up by their states, and then running some aggregate function like an average or a min or a max or a count on them. So this is a cool feature. This is very much like what we did in spreadsheets when I did COVID and I was looking at the Hudson Valley rates for COVID, and I broke up the COVID stats by county and then added them all up. This is a very similar kind of a process that I'm doing here. So obviously you want to take some time to look through my slides, try these out on your own, these commands, get your head around what they're doing. I'm just giving you the quick overview of what this is all about. What if we wanted to do, okay, I already just did that. What if we wanted to do the school districts in descending order, like which states have the most and which states have the least school districts? So let me do that. I just have to do an order on this, right? So I can do the same results I did, but just order them. So I can say, select the state and the number of unique school districts from this data, group by state, order by the count that we just did in descending order. So which state has the most school districts? Texas, 1,022, followed by New York, 668, it's a lot. Ohio, that's Michigan, yeah, Michigan, Pennsylvania, right? So some big states going on here. If I wanted to just go to the top 10, I could say limit 10, right? So just show me the top 10, let me get the hang of it. So those are probably your most populous states. That's probably why they have the most school districts, but it may not be exactly the 10 most populous states. California is not listed here, which I think is one of the top populous states. I can do it in reverse order. I can say in ascending order. So, what are the smallest? Limit 10. And we've got various results here. So DC, 1 school district. That's Hawaii, 1 school district. Puerto Rico, 1 school district. I guess I imported the headers. I must have done that accidentally. Delete from SD where SD state equals SD state. I think I imported the headers accidentally, and let me just remove those. Okay. Select star from SD. I just wiped out all my data. How did I do that? I don't know. Where SD state equals SD state. Okay. Well, anyway, I guess that's a good place to stop. I just wiped out all my own data, but I'm towards the end of my presentation anyway. The grouping thing is really what I wanted to end at. which is the end of my slide deck anyway. There are a couple more examples I have in here of grouping, but I'll let you walk through them yourselves. I'll just give you a quick intro. We've already done a lot of these kinds of things. And we can go further. So for example, if I wanted to do a bunch of states grouped together and do some analysis of those. So here I'm saying, get me all the states that are in this list of states. So where the state is either Maine or Vermont or New Hampshire or Massachusetts or Rhode Island, I'm kind of doing a where clause that is going to match any record where it's one of those values. And I'm asking for the name of the school districts, the state, and the population from any of those here. So that's going to give me all the school districts in what we call New England of the US, right? The northeastern area. And order by the population in descending order, and just show me the top 10 school districts. So out of all the school districts, I'm asking for those with the top populations in descending order, and only going to show me the 10 most populous school districts in any of these states. So this is a way that you would match not just one value, but where state is one of a list of values that I'm interested in. That's the difference here, is the where clause is matching the state to a group, and the state of any one record could be any one of the group that I'm mentioning here, if it's going to match. We've already done some information on density. I'll skip this stuff. You can read through it. Okay, that's it. So that's it. There are obviously a couple other queries I haven't gone into detail in, but the main themes, we've covered all of them at this point. So I'll let you guys try out the other ones like density that I've just skipped.